Okay, we're going to get into integration, but before we do that, we're just going to derive a function here that has the number e to it. Okay, and then we'll work our way backwards. So if we were to derive this function here, we would first of all recognize that that's a constant, right? And a constant will disappear. So we're really deriving this over here, and so we have 3/4 e to the power 4x. Now what is the derivative of e to the x?
E to the x.
It's e to the x, it's itself, isn't it? I'll just make a note of that. So the derivative of e to the x is equal to e to the x. It's the only function that will do that. Okay, it makes it special.
So does that mean that it just can't be derived? Or?
It can be derived. And the derivative of a graph that looks like this, that passes through 1, looks like this. Okay, so that's the derivative of that, and if you want to integrate that, you get this. It's the same thing. Okay, that's the special value e. Okay.
Is that 2.7?
Yes. Okay, so the derivative e to the 4x is e to the 4x times by the derivative of 4x, which is 4. Okay, and you could say that we've derived the outside, now we've derived the inside. Okay. This 4 will cancel with this 4, and so we get 3 times e to the power 4x. Okay, and what happened to the constant? It's gone. All right. So, if we're going to integrate this now, it's just the reverse. Okay? So, the integration of e to the 4x is e to the 4x. That 3, we'll just bring it down. And instead of multiplying the inside, we're going to divide the inside. So instead of timesing by 4, we're going to divide by 4. Don't forget to add the c now that the integration sign is gone. And we're left with 3/4 e to the 4x plus c. Does that look like where we started? Yes, it does. Okay, thanks, Eddie.